The next topic is flip-flops with additional inputs. Let's take our conventional D flip-flop. The D flip-flop has the D input and a Q output and a clock signal, right? But these are not the only inputs that a D flip-flop has. In commercial designs or in commercial D flip-flop designs, there are additional inputs as well. The first additional input is the clear N signal, and the second additional input is the pre-N. Clear N and pre-N are both active low signals or active low inputs, and they are represented as follows. That's clear N. So that's the line with the knot indicating it's an active low input, which means that 0 is going to activate clear N, and the second is the pre-N. So using these additional inputs, we are able to initialize the value stored in the flip-flop. How we are able to do that is, if we set clear N to 0, then output Q is guaranteed to be 0. And for pre-N, if pre-N is set to 0, then your output Q is guaranteed to be at 1. When you design this, you have to be careful to not make pre-N and clear N 0 at the same time. If you do that, your Q is going to go to 0 or 1, and you never really know what is going to happen. So you need to be really careful with that. So this is known as clear N, and this is known as preset. So clear indicates that your output is going to get cleared. Preset indicates that your output is going to be 1. Clear N and pre-N can be asynchronous or synchronous. So clear N and pre-N, they can either be asynchronous signals or they can also be synchronous signals. So when I say asynchronous, it means that whenever clear N or pre-N goes to 0, irrespective of the rising edge of the clock, your output is going to be at a 0 or a 1. So irrespective of rising edge of the clock, or it can be a falling edge as well, depending upon your design. So irrespective of the rising edge of the clock, if clear N equals 0, then output equals 0. Or if pre-N equals to 0, then output equals to 1. When I say synchronous signals, it means that it is going to depend on the rising edge of the clock. So at rising edge of the clock, at rising edge, if clear N equals 0, then output equals 0. If pre-N equals 0, then output equals 1. So in case of your synchronous designs, your signal values or your clear N and pre-N are only going to be sampled at the rising edge of the clock. In asynchronous mode, irrespective of the rising edge of the clock, whenever your clear N goes to 0, your output is 0.